Hey there, science fans! Have you ever wondered how a cake bakes or why fireworks explode in a burst of color? The answer is simple: chemical reactions. They're happening all around us all the time. So, what exactly is a chemical reaction? Imagine you're building with Legos. You start with individual bricks, but then you snap them together to create something new, right? That's kind of like a chemical reaction. In a chemical reaction, we start with ingredients called reactants. These reactants are like our Lego bricks. They interact and rearrange their atoms, those tiny building blocks of matter, to form brand new substances called products. Why does this happen? Well, everything in the universe wants to be stable and happy. Sometimes atoms find that by sticking together in new ways, they can be more stable. It's like finding the perfect spot for your Lego creation. Let's look at a simple example. Burning a piece of paper. The paper is our reactant, and the air around it contains oxygen, another reactant. When we strike a match and light the paper, we're providing the energy needed to kick-start the reaction. As the paper burns, it reacts with the oxygen in the air. The paper turns black, and smoke rises. These are the products of the reaction. The original substances, paper and oxygen, have transformed into something new. The burning paper is a great example of a chemical change. We can't get the original paper back, no matter how hard we try. That's because the atoms in the paper and oxygen have rearranged themselves to form new molecules like carbon dioxide and water vapor, which are released into the air. Chemical reactions are all about change. They're responsible for the amazing diversity of substances we see in the world around us. Just like there are different types of parties, birthday parties, pool parties, costume parties, there are different types of chemical reactions. Let's meet the main players. Imagine two friends joining hands to become best buddies. That's synthesis. Two or more reactants combine to form a single, more complex product. It's like adding ingredients in a recipe to make a delicious cake. Remember that Lego creation we built? Decomposition is like taking it apart. A single reactant breaks down into two or more simpler products. Think of it like a banana decomposing. It starts as one thing but breaks down into smaller parts. This is like a game of tag. One element in a compound is replaced by another element. It's like when one friend in a game of tag tags another friend, and they switch places. This is like a square dance. Two compounds swap partners, with positive and negative ions switching places. It's like when two couples switch partners in a square dance and everyone gets a new partner. This is the life of the party. It's a rapid reaction between a substance with an oxidant, usually oxygen, to produce heat and light. Think of fireworks or a bonfire. They're exciting examples of combustion. Remember that chemical reactions are like recipes? We need the right amount of each ingredient to make sure everything turns out perfectly. That's where balancing chemical equations comes in. A chemical equation is like a recipe written in the language of chemistry. It shows us the reactants, the products, and the proportions in which they combine. To balance a chemical equation, we use coefficients, which are numbers placed in front of the chemical formulas. These coefficients tell us how many molecules of each reactant and product are involved in the reaction. It's like making sure you have the right number of eggs, cups of flour, and teaspoons of sugar in a cake recipe. Section 5: Net ionic equations, focusing on the action. Sometimes chemical equations can get a little crowded, with lots of ions, which are atoms with a positive or negative charge floating around. Net ionic equations help us focus on the real action. Let's say we're mixing a solution of table salt or sodium chloride with a solution of silver nitrate. When we mix them, something cool happens. A white solid, called silver chloride, forms and falls to the bottom of the beaker. The net ionic equation for this reaction shows only the ions that are directly involved in the formation of the solid silver chloride. It's like watching a replay of a football game and seeing only the touchdown. We get to see the most important part. Section 6: Chemical reactions. They're happening everywhere. Chemical reactions aren't just for science labs, they're happening all around us, all the time. Fireworks, for example. The brilliant colors and loud booms of fireworks are the result of carefully controlled chemical reactions. Different chemical compounds are used to create a rainbow of colors, from bright reds and greens to dazzling blues and purples. Baking is like chemistry in the kitchen. When we mix ingredients and bake them in the oven, chemical reactions occur that transform the raw ingredients into a delicious treat. For example, the heat from the oven causes the proteins in eggs to denature, giving cakes and cookies their structure. Have you ever noticed how iron objects left outside can develop a reddish-brown coating? That's rust, and it's formed by a chemical reaction between iron, oxygen, and water. Rust is a common example of oxidation, a type of reaction where a substance loses electrons. Section 7. Try this at home, the fizz factor. Ready to try a fun and easy chemical reaction at home? Here's what you'll need: baking soda or sodium bicarbonate, vinegar or acetic acid, a tall glass or jar, and a balloon. Instructions. 1. Carefully pour about an inch of vinegar into the glass or jar. 2. Use a funnel, or carefully spoon it in, to fill the balloon about halfway with baking soda. 3. Attach the balloon to the top of the glass, making sure not to let any baking soda fall into the vinegar yet. 4. Hold the balloon upright and let the baking soda fall into the vinegar. 5. Watch the reaction. What's happening? When baking soda and vinegar mix, they react to produce carbon dioxide gas, which inflates the balloon. It's a simple but exciting demonstration of a gas-producing chemical reaction. So there you have it. A whirlwind tour of the amazing world of chemical reactions. They're the building blocks of change, responsible for everything from the food we eat to the air we breathe. Keep your eyes peeled and your mind open, and you'll start to see chemical reactions everywhere you look. Now it's your turn. What's your favorite type of chemical reaction? Can you try balancing a simple chemical equation? The world of chemistry is waiting to be explored.